When I did my A-levels decades ago, one of the fun things that our particular board did was after you'd finished all the labs, you got to do your own project. We took, I think, about 3 weeks in lab in which we made a new compound. Now, a lot of people just sort of did derivations of the experiments they'd done, but my dad was an organosilicon chemist, and I thought it'd be fun to make an organosilicon compound. That's an organic compound in which you've got silicon in there, silicon bonded to alkyl groups. And so we did this, and it was great fun. And we had to use a reagent called a Grignard reagent that you couldn't allow water to come anywhere close to it. You had to use ether as a solvent, and ether, of course, was great fun for a bunch of 16 and 17-year-old students to use. And it was generally a really nice experience. But I remember thinking at the end of it, wow, this Grignard reagent things are really, really useful. Why are they not in the A-level curriculum? And 40 years later, I'm looking at the curriculum and I do not see Grignard reagents, and I'm thinking, why are they not in the curriculum? But that's okay, because it provides me with something to talk about as an extension topic. Grignard reagents, first discovered by Victor Grignard, who won the Nobel Prize in 1912. So the 12th Nobel Prize awarded, which tells you this is pretty significant stuff. Now, a Grignard reagent is what you get when you take an alkyl halide, so I'm just generally calling it RX, react it up with magnesium, and effectively the magnesium inserts itself into the RX bond. Now think about the chemistry of this. Magnesium, of course, metal positive. X is a halide, so you expect that to be negative, but this R group is going to have a significant negative character to it. It has a significant carbanion character to it. So some examples of Grignards. You can make methyl Grignard, react up methyl chloride or chloromethane with magnesium. You can make phenyl Grignard, phenyl magnesium bromide, by simply reacting up phenyl bromide here. Remember, that's a phenyl group with magnesium. Magnesium inserts into the bond. You make this reagent here. Both of these very, very useful Grignard reagents. Now, you have to do this under anhydrous conditions, as I said, using anhydrous ether, which nowadays is called the very boring ethoxyethane. If you do it in water, it makes an alkane. What happens is that the Grignard reagent sees the water. Water, of course, slightly positive hydrogen, slightly negative CH3, get together to make methane and the basic magnesium chloride, magnesium with a hydroxide and a chloride. If you have too much CO2 around, then the Grignard reagent will make the carboxylic acid. Same idea. Here I'm going to use ethyl Grignard agent, ethyl magnesium chloride for my example. You have CO2. Of course, we think of CO2 as being a non-polar molecule, but it has a nice polar carbon-oxygen bond. Carbon slightly positive, oxygen slightly negative. Up here, the carbon attached to the methyl group, slightly negative. The magnesium, I said methyl, I meant magnesium. Carbon attached to the magnesium group, slightly negative. Magnesium quite a lot positive. So you get some interactions there, making this intermediate. React it up with H+, and now you can do it with a little bit of aqueous acidic conditions, and you break off the MgClOH, again making them a basic magnesium chloride, and you're left behind with the carboxylic acid. There's the carbon double bond oxygen, OH group. So Grignard reagents, do them very carefully, otherwise you'll turn them into an alkane, or if you have too much carbon dioxide around, you'll make the acid. But they are extremely useful reagents, as I said, and the big application of Grignard reagents in organic chemistry is to make alcohols when you react them with carbonyl compounds. That's why I'm doing it as this extension material, because the really useful thing you can do with Grignard reagents is you can make alcohols that have more carbon atoms in them. So here's a Grignard reagent. React it up with methanol, and you'll make a primary alcohol that has one extra carbon. So there's the R group associated with the Grignard reagent. There's the R group there, and you have the CH2O floating around there. If you take a Grignard reagent, react it up with a general aldehyde, not just methanol, then you will not make the primary alcohol, you make the secondary alcohol. One of the groups in the secondary alcohol comes from the aldehyde, the other one in pink comes from the Grignard reagent. And so if you take methanol, in which you've got 2 hydrogens, react it up to make a primary alcohol, you take an aldehyde in which you've got 1 hydrogen to make a secondary alcohol, then if you take the carbonyl compound, the ketone that has no hydrogens, react it up with the Grignard, you'll make the tertiary alcohol. 2 of the groups come from the original ketone. The third R group comes from the Grignard. Mechanism of this, and I'll just do it for the ketone reaction. Let's again use our ethyl, Grignard, ethyl magnesium bromide. React that up with the ketone. You've got the slightly positive carbon, the slightly negative carbon of the Grignard reagent. Those come together, and that makes the carbon-carbon bond that is so special about this reaction here, leaving yourself with the O-. At this point, you can quench the reaction by putting in some aqueous acid, and you acidify the O to turn it into the alcohol. So Grignard reagents will react with carbonyl compounds to make alcohols. Hugely, hugely important synthetic reactions. First of all, you increase the number of carbons. You can put however many carbons you want into this molecule at the appropriate carbon there, depending upon which Grignard you use. Here I'm just sticking in ethyls all over the place for my particular mechanism. But then you end up with an alcohol. And alcohols are very, very easily converted to other groups, as you saw to an extent in our alcohol module. So a very fast extension topic on an extremely important organic reagent. Grignards, you can do all kinds of things with Grignard reagents. However, the big one, reaction with carbonyl compounds to make primary alcohols when you do it with methanol, secondary alcohols when you do the reaction with aldehydes, and tertiary alcohols when you do the reaction with ketones.